Okay, so if you remember from last chapter, a quadratic relation can be represented in standard form. Do you remember this equation? Y equals ax squared plus bx plus c. Who remembers what a tells us? The number in front of x squared. Remember we did a bunch of stuff on this. I showed you on Desmos. If the number in front of x squared is positive, so if I have a positive number, let's say 5, what does it tell us about the parabola? If a is positive, if it's a positive number, what does it tell you? If a is positive, it opens how? Up. Okay, so let's write this down. It opens up, or you can highlight it. If it opens up, does it have a maximum value or a minimum value? Minimum, right? Because this is the lowest point it can go. Do you remember this? If a is negative, so if I have y equals, let's just say negative 2 x squared, does it open up or down? So it looks like that. And then, of course, we have the highest point, which means it has a maximum value. Okay, do you guys remember this? When it's written in standard form, so in this form, ax squared plus bx plus c, do you remember what c tells us? What is the c value equal to? Who remembers? What does c equal to? So anytime it's written in standard form, you have a x squared plus bx, don't worry about that right now, plus c. C is always going to represent the y-intercept. Okay, does that make sense? So if the equation is the c value is the constant term, it's the number that's by itself. It does not have a variable next to it. It doesn't have an x squared. It doesn't have an x. It's just the number by itself. It represents the y-intercept. If this is the equation, the first example, x squared plus 2x minus 15. Which one of those numbers represents the y-intercept? What would be the y-intercept in this example? Is it 2? What is it? What's the y-intercept? So in this example,
15?
Positive or negative? Negative 15, good, is the y-intercept. So that's the answer for B. How would I write that as a coordinate? 0, negative 15. A y-intercept always starts with 0. In a y-intercept, x is always 0, and then the y value is always the y-intercept, right? If x is not 0, it's not going to hit the y-axis. What is the a value? Is there a number in front of x squared? So what number do we imagine is there? 1. Is the a value positive or negative?
Positive.
It's positive. So is this parabola going to open up or down?
Up.
So is it going to have a maximum or a minimum?
Minimum.
Okay, good. You just answered question A. It has a minimum value. So we know it automatically just by looking at it, not graphing it, doing nothing. We look at it, we know it has a max or min value. We know if it opens up or down, and we know what the y-intercept is. Now this is the hard part. Determine the zeros. What's another name for zeros? Do you remember? The x-intercepts. Well, what do you know about x-intercepts? They cross the x-axis. Excellent. So might have something like this. In an x-intercept, if you're writing the coordinate of an x-intercept, it would be x, whatever x is, the number, and followed by 0. Y is always 0 in an x-intercept. Do you remember this? If the y value is 0, then you know that the x value is your intercept. So how on earth are we going to figure out the x-intercepts of this? So we're trying to figure out the x-intercepts, right? And we know that it's the value when y is equal to 0. We're trying to figure out what is x equal to. So I'm trying to solve for x when y is 0. So if I write x squared plus 2x minus 15 equals 0, I'm trying to figure out what x is equal to. But right now, looking at that, we can't solve for x, right? Because we have an x squared and we have an x. So what you're going to do to find this is you're going to factor. Remember factoring? I'm looking for two things that multiply together to give me back this original question. So I know that the first terms are going to be x, right? Because it's x squared. X times x is x squared. And then we're doing the product sum method. Do you remember this from before the break? So I'm looking for two things that multiply together to give me c, which is negative 15, and adds up to b, which in this case is positive 2. Do you remember this? So you said 3 and 5, but it's negative 15. So one of them has to be positive, one of them has to be negative. So it could be negative 3 and positive 5, or positive 3 and negative 5, right? Well, let's see which one adds up to positive 2. What's positive 3 plus negative 5? Negative 2. What's negative 3 plus 5? Positive 2. So this is the answer. So we're going to put those numbers here. So it's got to be negative 3 and positive 5. So it's going to be x take away 3 and x plus 5, right? Those are the two factors. Okay, well now we have x minus 3 equals 0, right? Both of these are equal to 0. And we have x plus 5 equals 0. What we were trying to do is we were trying to find out what does x equal. If x minus 3 is equal to 0, what does x equal? 3. If x plus 5 is equal to 0, what does x equal? Negative 5. Does it make sense that this has two x-intercepts? Yeah. Bring this to the other side. What's the opposite of plus 5? Minus 5. What's the opposite of negative 3? Plus 3. You're given the equation in standard form. We are going to factor it. So we use the product sum. These are the factors. And then set each of these factors equal to 0 and solve for x. What we're trying to do is you're trying to find out what x is equal to. These are the x-intercepts. So if I were to sketch this equation, I know it has a y-intercept of negative 15, right? We already know that because this is c. We figured that out already. And it has two x-intercepts. It has a y-intercept of negative 15. So let's say that's down here. That's my y-intercept. And it has two x-intercepts. One of them was what? What were the two x-intercepts? Negative 5, and what was the other one?
3.
So would you agree that it passes through these points? Did it open up or down? Up. So this is my sketch. Look here. Oops. Okay, that's not the vertex. The vertex is somewhere around here, which is what we're going to actually figure out right now. So we're going to figure out the vertex. Does everyone understand it up to this point? The vertex goes through the middle of the parabola, right? So it's actually, I didn't sketch this very well, but this should be more like this. It's actually halfway between the two x-intercepts, right? Does that make sense looking at it? The vertex runs halfway between my two x-intercepts. So can you figure out halfway between negative 5 and 3? Can you figure out the midpoint, the halfway point? How would I figure out half of something? I would add them together, negative 5 plus 3, and then divide it by 2, right? I need to know altogether, negative 5 plus 3 is what? What's negative 5 plus 3? Negative 2, right? And then divide that by 2, what do I get? Okay, does this make sense? The vertex is located, look here, at negative 1, and I don't know what the y value is. It's going to be below this negative 15. It's somewhere down here, right? Does everyone understand that so far? I need to figure out what is this minimum value. What is the lowest y value? Well, if I know the vertex, which is what we're figuring out, then I know the lowest value. I know the minimum value. So the vertex is located at -1 and something. Well, -1 is the x value. That's the axis of symmetry, right? If you know x and you know an equation, can you figure out y? Plug it into the equation. Did the equation have an x and a y? Okay, so let's plug it in. What was the equation? Y equals x squared plus 2x minus 15. If x is -1, we can figure out what y is, and that will tell us the point of the vertex, because I'm plugging in -1, which is part of my vertex. So let's plug it in. So -1 squared plus 2 times -1 minus 15. Bad math again. Okay, so this is the x value of the vertex, which is the axis of symmetry. If I know the x value of the vertex, I plug it in, and we can figure out the y value of the vertex. Right? So what is -1 squared? And 2 times -1? -2 minus 15. What's 1? Take away 2, take away 15. So y is equal to, if you simplify this, 1 take away 2 take away 15 is -16. Does this make sense? Does it look like the vertex is located at -1, -16? That's reasonable, right?